Last classes we have discussed about the deep learning. Deep learning means detailed learning. Okay. Deep learning means it is going to detailedly, it is going to learn means by multiple times. It is going to learn multiple times, not in terms of one time. It is not with respect to the formula wise or something like that. It is going to learn multiple times. Now, what is learning multiple times means? For every time it learns, it identifies the error. First time it will learn. It will identify the one error, and a second time it will learn. Once again it will learn, again it will identify the error, again third time it will learn, identify the error, and every time it will try to reduce the error. Every time it will try to reduce the error. Sir, the same thing we have seen in the boosting also, same, right? So in the boosting also, first decision tree one will be done, and in the decision tree one, whatever the errors are there, that error will be reduced in the second decision tree. The error will be tried to reduce in the third decision tree. The errors will be in each decision tree, the overall error will be minimum. Where decision tree to decision tree, the error is going to be getting less. Now the same concept is applied here also in the deep learning, right? Deep learning works in a different way, where it is going to have based on the neurons. There'll be some neurons will be there, and the neurons will pass the information. So here we are having some kind of neurons. Okay. So neurons, and the neurons will work on this. So this is one of the types of neurons. Neurons in the body. This is called as biological neuron. So where the biological neurons are connected to each other, multiple neurons are connected in the body with respect to, yesterday as one of the students has told that it is almost 86 billion neurons are there, right? So here, if you see in the body, we are having the multiple neurons are connected to each other. They are passing the information. So here also the same thing. What is this? This is called as biological neuron. Biological neuron means which is available inside the body. Now this biological neuron, what it is going to do means it is going to work based on the dendrites and axon, and it is going to pass the information. Means these are called as input. This is called as input. Means it is going to color the information. Input means nothing but collecting the information. First neuron will color the information. For example, I am speaking to you and you are listening. Your ears, whatever the ears are there, in the ears, the first neuron, whatever the first neuron, it is reaching to that ear, it is listening. Whatever I am speaking, it is listening. And once this is done, the input, once it is collected, it is processing. And it is sharing to the next neuron. And next neuron, again, whatever the next neuron are there, again, they are connected to each other. The neurons are connected one to one each other, as we have seen in the Avatar movie, right? So they will be connecting with respect to whatever the hair they are having, they will connect with respect to the animals. So they're having the bond. The bond is in terms of neural network. They are going to create with respect to whatever the neurons they are having, they are creating with respect to them. So here the neurons, whatever the neurons we are having, the neurons are connected to each other. In each neuron, some process will be done, and it will pass the information. After processing, it will pass the information. Once it takes the information, first step of neuron, any neuron, it involves with respect to first, it will collect the data. It will collect the data, and that data, whatever the collected data is there, that will be processed, and it will share the information to the next neuron. Share the information. Whatever the processed information is there, processed information, it is going to share to the next neuron. And like this, the every neurons are connected to each other. So this first in your ears, whatever the neurons are there, ear neurons are getting connected to the brain directly. And from the brain, it is connected to your hand. So if you feel that brain says that it is an important point, please write. It says like that in your brain, automatically you'll write. If you feel that is not an important point, you will not write. So whatever the process is there, the internal process, this process is passing the information between the neurons. So processing the data and passing the information from one neuron to another neuron is called as network. A network, what is meant by network means multiple neurons connected to each other. Network means neurons connecting to each other. If the neurons are there, one neuron and one neuron, they're not having any connection, then it is not called as a network. They are just called as neurons. They are called as multiple neurons. But the same multiple neurons are connected to each other. If they are connected to each other, the connection, whatever the connection they are having between them, this connection together set of this one is called as network. Since in the network, which are connected? Neurons are connected. So neurons are connected. So it is called as neural network. If the neurons are connected, it is called as neural network. Friends are connected means friends network. Relatives are connected means relatives network. Whoever are getting connected, that is the network. So here neurons are getting connected. So it is called as neural network. And network means connection. Basically, network means connection, right? So here the neurons are connected to each other. Multiple neurons are connected to each other. In a biological neuron, how they are connected to each other and processing the information and sharing to the next one. Why we can't create the same type of neuron artificially? One neuron they have taken. I am showing in a circle. Okay. Now one neuron they have selected. Now this neuron, they are going to take the information. And in this neuron, they are going to do the processing. And they will send the output. For any neuron, information will come. It will do the process and it will do the send that whatever the after the processing, whatever the output is there, it will share to the next neuron. Next neuron, once it got the information, again it will also process something and it will also share to the output. Like this, how many neurons are connected to each other? Each of them are processing and sharing to the next one. Connection, sharing, connecting and processing and sharing, processing and sharing. So each neuron is doing the process and they are sharing the information. Now, here the most important point in the neural network is neurons, connections, how they are connected to each other and how they are going to work. Okay, so first neurons means artificial neuron. Artificial neurons means nothing but a neurons where it is going to process the information, right? Now here in the last class, I have told you that we are having the input neurons. Some kind of input neurons will be there. Similarly, some output neurons will be there. Set of input neurons is called as input layer. If one neuron or two neurons or three neurons, whatever we are having, input layer. Now the question is, how many number of input neurons we have to consider? First starting is this one. Okay, is equal to, the answer is number of futures, number of input futures. Number of futures, how many you want to train? How many futures you want to train? Initial data will be so many. After that, you are going to drop, right? Initially, for example, if you go with one of the column, like name is there, you are dropping that name. Serial number is there, you are dropping that one. If any other columns are there, unimportant futures you are dropping. Which futures you are using for training purpose? Xtrain. In the Xtrain, what is the shape? Xtrain dot shape. Xtrain, whatever the Xtrain dot shape is there. In that shape, we are having the number of columns, right? The number of columns, the shape you are going to get output. Whatever the shape output is there, you are going to get the shape as, for example, 400, 12. Now, what is meant by 400? Number of records. What is meant by 12? Number of futures. Now, whatever the training you are using here, 12 futures, then 12 input neurons you have to select. Whatever you are using for training purpose, those futures you have to select, not original raw data futures. Which is you are going to use for training purpose. After dropping off, doing the future selection or whatever it is, finally, how many futures you are going to give as the input, that futures you have to select. Example, like a TV, radio, newspaper. Output is says. I'm having like this. Now for this data, what I'm going to do, I'm going to select 3 input neurons. 1, 2, 3. 3 input neurons. And this is called as input layer. Because 3 input values are there. Now let us take one more data set where we are having with respect to like a mall customer data set is there. Inside that, what we have done, first column is customer ID. Customer ID is important for us. No, right? We are going to drop. Whatever you are considering the X, overall X, before trying to split in the X, whatever you are considering, that is more important. Right? So which is the part you are using for training purpose, the number of futures you have to give here. Now, what happens once you have given this information? Now, this is the input layer. So number of input neurons is equal to number of input features. Is that clear? Is there any question? No? Done. Input layer is completed. Now coming to the output layer. Next heading is output layer. Okay, how many neurons in input layer is completed? So question is, how many number of neurons in input layer is equal, answer is number of input features used in X-train. In that while fitting the data, used in X-train while fitting the data to the model, while fitting the data to model. Number of input features, how many you are having, those many number of neurons you have to consider. Question number 2. How many number of neurons in output layer? How many number of neurons have to consider in the output layer? Right? Now the answer for this one is, you have to consider 1 if it is regression problem. If it is regression, you have to consider 1. For regression, 1. Now is equal to again 1 if it is binary classification problem. For binary classification also we have to take 1 only. Is equal to n, where n is equal to number of categories, where n is equal to number of categories in output variable. And this n will be used if it is multi-class problem, multi-class classification model. Multi-class classification model means n. For binary class 1, for regression 1, and for multi-class n. Now for clustering will not be done using ANN. Recommendation engines will not be done by using ANN. Next, with respect association rules, nothing will be done by using ANN. Nothing will be done. Unsupervised machine learning cannot be done with ANN. ANN is used only for supervised data. That is labeled data. ANN is applicable only on the labeled data. ANN is not applicable on the unlabeled data. Right? Labeled data. Labeled data means output variable should be available. Okay. ANN is used for ANN is applicable only for labeled data. Labeled data means output variable is available, is called as labeled data. If the output variable is not available, then it is called as unlabeled data. ANN is used, for regression and classification purposes only. It is used for only regression and classification purpose. Okay. For unsupervised one, unlabeled data, that is where output variable is not available, we are only having the option is machine learning. Deep learning is not applied on that. We can't apply the deep learning, any of the deep learning concept on the unsupervised. Right? That is unlabeled data. Is that clear? How many output neurons you have to consider? Now, example, heading as example, TV, radio, newspaper, and says. If you are having this one, this is the data set. For this data set, where I am considering x is equal to df of TV column, radio column, newspaper column. 3 columns I am considering. Whereas y is equal to df of says. Now, in the x, how many features I am using for training purpose? 3 features are there. So I have to use 3 neurons. And this is called as input layer. Now, this is a regression problem or classification problem? Regression problem. For regression problem, how many output neurons I have to consider? Only 1. And this is called as output layer. Is that clear up to here? Now, after this, done, written. Now, next. In the x variable, how many features are there? That many input neurons should be there. Before train test split, you are applying that x, what are the x? Indirect, before train test split or after train test split also, the same thing. Whatever you are using for training, fitting the data into the model, how many features you are going to use? That many features. Sir, why that many features? This, for example, first record, some value, 2 lakhs or 2000, assume that 200 or something. Let us assume 200, 2000, 100, 40, something you are having. This first record will be, this value will be sent into here. This value will be sent into here. This value will be sent into here. Each value will be sent into that particular neuron. Second record, again you are having one more record. Once the first record calculation is completed, now the second record will be sent into, the second record T will be sent here. The second record, what are the radio values there, that will be sent into this. What are the newspaper values there, that will be sent into this. And it will pass the information. Getting the point? So that is the reason how many input neurons are there. This one also should be the same. For example, here 4 neurons are there. 4 input features are there. One more input feature also is there, that is called as XW something. The name of that feature name is XW. Now for XW, you are having some value of 250. Now this 250 from where you will send, in which neuron you will send? This 200 or 2000 you are sending from this, 100 you are sending from this, 40 you are sending from this. From where you will send this 250? To the neural network it has to send, means some neuron should be there, right? Initial neuron should be there. That initial neuron we are not having. So it is going to throw an error that number of input neurons and the input features are mismatched. It will throw the error that mismatch. So the number of input features, whatever you are having, the number of input neurons should be the same. Then only it will pass the information. Right? Now, next one is that clear, guys, till now? Next one is, how many, not how many, don't write. Okay. If you have the connection, connecting directly the input layer, connecting directly the input layer to the output layer. If you connect directly the input layer to the output layer, then it is called as, perceptron model. Then it is called as perceptron model. Example, input layer earlier, whatever the 3 neurons you have taken, output layer 1 neuron you have taken, connect them directly. Give the connection directly like this. It is called as perceptron model. Connecting directly the input layer to the output layer. Connecting directly the input layer neurons to the output layer neurons. Okay. Our input layer neurons to the neurons to neurons. You are going to connect the neurons. Layer is the word we have created for our understanding purpose. Layer word will not be there inside. Okay. So neurons only will be there. Neurons will be connected. Right? Then it is called as perceptron model. Done. Next, if in between input layer to output layer, if in between input layer to output layer, if between input layer to output layer, if we have hidden layer, then it is called as neural network. Then it is called as neural network. Artificially created, so it is called as artificial neural network. So between input and output layer, if you have a hidden layer, in between one more layer of neurons, not directly connected, indirectly are connected to each other, then it is called as a neural network. Example, input layer, output layer. This is a hidden layer, in between hidden layer. You are connecting like this to this one. You have to connect actually this one to this one directly, but you are not connecting directly. You are connecting between, using a hidden layer, you are connecting, right? You are using a hidden layer and you are connecting to the output layer. Then it is called as a neural network. Okay, then it is called as a neural network. In between, if you are having any kind of hidden layer, then it is called as neural network. Now, sir, in the neural network, this starting, whatever in the starting portion is there, automatically it is called as input layer. Whatever is in the end, it is called as output layer. In between anything is there, it is called as hidden layer. The first one, last one is fixed. Center one may be available, may not be available. Right? Done. Next, how many number of hidden layers should be there is the question. How many number of hidden layers should be there? Answer is minimum 0 to minimum is equal to 0 to maximum of infinite. The value from 0 to infinite. If you take 0 means it is called as perceptron model. To infinite will be there. Then how we select? Number of hidden layers. Then how we are going to select the number of hidden layers for the data? Again, answer is hyperparameter tuning. You have to do the tuning, which is not having any kind of overfitting, at the same time underfitting. There should not be overfitting, there should not be underfitting. We have to do the hyperparameter tuning. Next, immediately question is, how many neurons should be there? How many number of neurons in each hidden layer? Again, answer is hyperparameter tuning. This is also not a fixed answer. This one is not fixed answer. This one also not a fixed answer. For input layer only rule is there. For output layer rule is there. For hidden layers, there is no rule. For entire hidden layers, there is no rule. That depends upon the data set to data set. Okay. Rule applicable only for input layer and output layer. The rule is only applicable for input layer and output layer. No rule for hidden layers. Not even one rule also there. You have to select this many neurons, this many layers, this one only you have to select. Nothing is there. No rule for the hidden layer. None of the applicable. Nothing will be applicable. For input, everything is applicable. For output also, everything is applicable. Many things are there. Many things are applicable. But for output, hidden layer, nothing is applicable. None of them is applicable. Everything is hyperparameter tuning on. Automatically, sir, hyperparameter tuning means so much of time it will take, right? Compared to machine learning, artificial neural networks takes so much of time. When time is your priority, then we have to go with the machine learning. When time is not the priority, then we have to go with the artificial neural networks. Artificial neural networks gives better accuracy when compared to the machine learning, but more time it will take. Time is very high comparatively, right? Now, sir, as you told that number of hidden layers, infinite you can take. For example, if I take 500 hidden layers, can I take like this? Means your system will die. Okay. So, what type of data? Based on the data, we have to select. Not as per your choice. Whatever the number you are interested, we can't do that one. Just apply some kind of common sense, right? Not by basically. We have, see here, the most important point for artificial intelligence means the most important point, right in the notes compulsory. SRK is not responsible for your system. Okay. If you try as per your choice and if your system dies, I am not responsible. Okay. You are not checking whether your system is working or not. You want to learn the concept means try with a simple example. Give one layer and try with 2 neurons and see the calculation. You want to understand the concept or you want to check the system configuration whether it works or not. Right? So this is most important. Don't try with as per your number and sir, my system was died, sir. I have given to the service center, sir. Your motherboard gone means I am not responsible. Your processor or whatever it is. Okay. So while playing with the artificial intelligence, the configuration should be very good. So generally, which configuration is good? i5 with 8 GB RAM is sufficient. Generally, i5 with 8 GB. i5 of 6th generation also okay. That is not absolutely not a problem. But if you give more number of hidden layers or more number of neurons, processing time will be very high. Computational will be very high. Okay. How it is going to work, you'll understand now. After that, you'll only say how it is takes with more time, right? Now here, if you are working with the minimum configuration of i5 with 8 GB is sufficient. Okay, basic level of things. Sir, in the company, what type of configuration we require? Generally in the company. In the company, what type of configuration are required for that data, they are going to provide you. The system they will be providing, right? Whatever the system is there, they will provide for you in the company. Sir, in the company, if they have not provided, I think already I have told you, right? First, immediately quit the company. Okay. So generally, artificial intelligence, they have given someone for the people like structured data or unstructured data miss. Automatically, they are working on artificial miss. That is high level company only. They will provide automatically. Only for structured data, for machine learning only, basic configuration, basic things, junior data scientists, they may not provide. Some companies may not provide. But to my knowledge, till now, whoever the students has worked in the companies, for everyone, they have shared the systems. Okay. For practice purpose, don't worry. Okay, practice purpose, basic configuration also super. Okay, not a problem. Absolutely not a problem. Right? Now, here what we are going to learn is, first we are going to understand what is meant by neuron. Next, what is meant by activation function? How the neural networks works. How the neural networks learn the data. They'll understand the data. How they works and how they learn. And here the most important concept works is gradient descent is the algorithm. It is going to work on the gradient descent. And in the gradient descent, there is a problem. That problem was rectified by using stochastic gradient descent and backpropagation. These are the technical terms which we are going to learn. So first, what is neuron? And next, activation functions. Next, how the neural networks works, how the neural networks learns, and step-by-step process of the things. One by one, we are going to understand, right? Now, let us start with the first one. Here, the number of hidden layers. If the number of hidden layers is equal to 0, then it is called as perceptron model. If the number of hidden layers is equal to exactly 1, then it is called as neural network. If it is having more than one hidden layer, then it is called as deep neural networks. Deep neural networks. More than one hidden layer is there. At least 2 hidden layers are there also. It is called as deep neural networks. Okay, exactly one layer only is there, and it is called as generally a network connection. Right? Generally, it is called as. There will be no difference. Don't worry. In the exam, they are not going to ask any kind of what is the difference between neural network versus deep neural network. Both are same only. Nothing difference is there. Right? Now, so here, what is neuron? Any neuron. What is neuron? First, let us start with neuron, one by one. So, first one is neuron. Now, what is neuron? A neuron is, Shubham is asking i3 with 4 GB is not okay, sir. It is sufficient for basic things. Okay. So, whatever I am going to explain the example in the class, whatever the example I am explaining, that is sufficient with i3 with 4 GB also. Same thing, if you want to practice, miss, not a problem. If you want to try with more number of layers or more number of neurons only. One student has done like this. He has given 10,000 neurons. In the hidden layer, he has kept 10,000 neurons. Why he has kept, miss? I asked the question, why, miss? He has told that casual I have kept, sir. Casual only has paid the bill of 28,000. Motherboard, processor, RAM, 3 of them, Matash. 3 of them. And he has paid 28,000 for that. Casually only go and pay. What I can do? Casually you tried, casually pay. Both are casual only. Right? After this, from that time onwards, I am explaining for every student. Don't do as per your choice. The numbers, just as a learner, you want to learn, miss, you have to understand step-by-step process only, right? Now, for understanding step-by-step process, 10,000 neurons are required. To check whether it is underfitted or overfitted, 10,000 neurons are required. Just for 20 neurons also, you will get the same answer. I mean, same answer means you can learn, you can understand. Your requirement is for understanding purpose. If you want to take the number of neurons also, you have to increase the layers. At that time, he has done like that. Okay. Now, here, whatever the neurons we are having. Now, first, any neuron. What is meant by neuron? Neuron means it will collect the information, it will process the information, and it will send the information. Any neuron will have one, collect the information, process the information, whatever the information is, they process that one, and send the information. Whatever you have processed, send the information to the next neuron. Whatever it is connected to you, send to that. You can't send to the others, right? Whatever is connected to you, only you can send. So the neurons, it will collect the information, process, and it will send to the whichever it is getting connected. For that, it will send the information. Any neuron will do the same. Any neuron. Okay? Any neuron will do the same. Right? Except input neurons. Except input neurons. Input neurons, just they will take the information. From there only, the next step will start. So, now, let us take a neural network. 3 neurons. Okay? One hidden layer. I am taking one hidden layer. hidden layer is equal to 1, where the two neurons I'm taking. These are the two neurons. I'm going to give in a different color. Okay, and one output neuron. You are having like this, one input layer, hidden layer, and output layer. Okay, now you are going to make the connection. Okay, this is called as connection. Total how many connections you are going to get? Each one is called as connections. How many you are going to get means this neuron has two connections, this neuron two connections, this neuron two connections. So each neuron is having two connections of input layer with respect to 3 into 2, 6 connections are there. So you have to check this neuron which is got connected. Now this neuron has, what is the network of this neuron? How many neurons it has got connected? 3 neurons. From 3 neurons, it is going to take the information. Take information from 3 neurons. It will take the information from 3 neurons. From this neuron, it will collect the information. From this neuron, it will collect the information. From this neuron, it will collect the information. From 3 neurons, it will collect the information and it will process that one. And after that, it will share to the whatever it is getting connected. So to this neuron, it will send. And it will send this to this. Is that clear? So this neuron, from this one, every neuron, except the first one, this one, because this is got connected. This is not connected with the previous one, right? This is the starting one which was get connected to the others. This is the first connected so connection, wherever the connection is there, that will process. If connection is not there, no process. So this will collect the information from 3 of them. Let us take the 3 of them as W1, W2, and W3. These 3, whatever W1, W2, W3 connection is there, these 3 connections will be processed here. And it will send the information to the output. The output I'm going to write as O1, something like this. Choice is yours. You can write as per your numbers. I have written something like that. Now this neuron, whatever the second neuron is there, now this neuron was connected to this one, W4, W5, and W6. So W4, W5, W6, it will collect the information from these 3. And after that, it will process inside that and it will share the O2 for this one. Now this one, now this neuron, whatever this neuron is there, now this neuron is connected to which one? This one, this one. Only O1 and O2. So it will collect the information only from O1 and O2 and it will process. Whatever it has got connected, it will process only that one. Not the first one or before to that one. It will not do anything. Only to the whichever it has got connected. Is that clear? It will process the information of O1 and O2. And after doing the process, it will send the output. So next one is not connected, right? So whatever the output is there, that is the final output. If no connection is there, means that final answer, it will give us the answer. That will be displayed for us. The output will be displayed for us. Is that clear? So which neurons it has connected, that neurons it is going to collect the information and it will process the information. Now collecting part is clear, right? Now processing part will enter. Collecting part is clear, means processing part will enter. Right? So now whatever the data it has collected, right? So now it is going to work on that. It is processing and it is transferring the information. Dendrites means collecting the information, collects the information. In the body, dendrites will collect the information. Inside that, this is called as nucleus. Where nucleus or neuron, the main part of the neuron is nucleus, where here it is going to process the information. And axon will share the information to the next neurons, whichever got connected. For this dendrite, one neuron will be connected. For this dendrite, one neuron will be connected. Like this, multiple neurons will be connected to multiple things. Anything can be connected. Or everything connected to one only, maybe. Who knows? Whatever it is connected, it will share that information. Is that clear? If one is connected, means to one it will send the information. 2 are connected, means to 2 it is going to send. If 5 neurons are connected, means 5 neurons it is going to send the information. To how many it is having the network, it is going to share the information. Right? Now, Here, whatever the dendrites or information is there, it is just passing the information. Axon means it is passing the information to one to another, right? Now the neuron, whatever the neurons are there, they'll collect the information and they'll pass the output. Whatever the neuron, it will do the processing and it will share the information to the next level. Now the question is, whatever the information it is going to pass, I already told you how many number of input neurons you have to select means equal to number of input features. How many number of input features you are having? Independent variable 1, independent variable 2, like this. How many independent variables you are having? Those many independent variables you have to select in the input neuron. In the output neuron, you have to select if it is continuous or binary classification problem, 1 is sufficient. But if it is a multi-class classification problem, how many categories are there in the output variable? Those many number of output neurons. 3 classes are there. For example, we have worked on the data set called as penguin data set, where the penguin data set has the 3 things, 3 outputs are there. Like now that 3 outputs, it is a multi-class classification. In that case, we have to use 3 output neurons. For example, mushroom data set is there. For mushroom data set, we are having only 2. Then it is binary classification also, 1 neuron is sufficient in the output variable. So in the output variable, if it is continuous means 1, for binary classification also 1, for binary classification or categorical data, it is 1. If it is multiple means multiple neurons, right? Now, here what it is going to do? It is going to process the information. Now, the next question starts with process, heading as process. Okay, now what it is going to process? Neuron will process the information in 2 steps. In 2 steps, and then it will send the output. It will send the output. It will process in 2 steps. The information will be processed in 2 stages. 2 stages or 2 steps. Now, what is the first step? What it is going to do in the first step? First step is sigma wi xi plus b is the first step. What is this? You'll understand. Sigma wi xi plus b. What is the second step? Activation function. Neuron will process the information in 2 steps. One is sigma wi xi plus b. The second one is activation function. Okay. So now, what is meant by sigma wi xi plus b? Now, let us take this example. Okay, 3 neurons are there. 1 neuron in the hidden layer, first neuron, whether it is output neuron, hidden layer neuron, whatever it is, some neuron is there. For this neuron, you have connected these 3. These 3 are got connected. Now, the whatever the data set is there, that is x1, x2, x3 data set is there. This data set will be the first record, whatever the first record value is there, that first record will be sent into this one. For example, here 2000, 400, 950, 3 values are there. 2000 will be sent into this, 400 here, 950 here, right? And here the connections, whatever the 3 connections are there, these 3 connections are having with respect to weights. It is going to have some kind of weights. Now, what is meant by weights? Question is, what is meant by weights? Now, we have to go little back to the linear regression. Linear regression, y hat is equal to beta naught plus, if 3 input variables are there, then what is the equation? Beta 1 x1 plus beta 2 x2 plus beta 3 x3. Now, can I write the same thing as beta naught plus sigma I is equal to 1 to 3 beta I xi? Same thing, right? Starting from I2, ending with 3. Is that okay? Now, this notations beta naught and beta I. Instead of beta I, I'm writing as b naught plus sigma I is equal to 1 to 3 b1 xi bi xi. Can I write? Why? Because they are just notations only, na? Can I write as I plus sigma not I k plus I is equal to 1 to 3 li xi? Everything are same only, right? You can write beta naught or b or anything. It is compulsory y is equal to mx plus c only you have to write. You can't write y is equal to ax plus b. You can't write lx plus j. It is compulsory y is equal to mx plus c only. Is there any rule like that? Since we have studied like that, it is multiple times we have studied the equation y is equal to mx plus c, y is equal to mx plus c. It is equal to us. In India, the mathematics textbooks, they have written y is equal to mx plus c. But if you open the US textbooks, they have written y is equal to b naught plus b1x. They have studied like this. In their school days, they have studied the maths with a straight line b naught plus b1x. But whether it is a b naught or whether it is a c, finally the concept remains, it is y-intercept only. b1 or m, both are called as slope only. Concept is slope, concept is intercept. The notations are changed. Only the notations are changing. Notations only changes, not with respect to the concept. Concept will not change. Right? Notations only are changing. Now the same way, here, this is in the machine learning. Whatever the notations we are having in the machine learning is beta naught plus this one. The same notation they have brought in the deep learning as b plus sigma I is equal to 1 to 3 wi xi. Earlier I have written wxi plus b, right? That is the same. Both are same. Okay? Both are same. Here 3 means 3 variables are there. 4 are there means 4. 5 are there means 5. Means basically it is n. It is equal to n. How many number of input variables are there? Basically that is n. In this case 3 variables are there, so it is 3. 4 variables are there means 4. 10 variables are there means 10. Basically this is the n. So in machine learning, the linear regression equation was taken as sigma I is equal to 1 to n beta I xi plus beta naught. The same thing in deep learning they have considered as sigma I is equal to 1 to n w xi plus b. Notation only they have changed. Concept is same to same. Notation they have changed in the deep learning. Sir, why they have changed the notation, sir? Because that is invented by one scientist. This is invented by one more scientist. So they want to keep their as per their notations. Right? Sir, everyone can keep the same notations now. No confusion will be there, right? Generally, we will think from the student perspective. But from if you are inventing something means you want your own uniqueness in that. You don't want to copy others. If you invent something means never we want to copy others. Something we want to try our uniqueness. Something we'll keep. They have created like this. I also got the same question. When I'm learning, I also got the same question. Then I have realized that. So for example, I used to prepare earlier, once upon a time, that is almost 12 years back story, where few concepts I used to read in one textbook number 1. Few concepts I used to read in the textbook 2. Okay. I used to, after reading from textbook 1 and textbook 2, few concepts here, and few concepts I used to open the textbook 3 or YouTube channel, some YouTube. Of course, at that time, YouTube is not there, only textbooks. Not even book bank also not there. Google only, not Geo only is not there at that time. Okay, internet only not proper. Monthly, we used to get 2 GB. That too, for that monthly 2 GB, we have to pay 800 rupees. 799 is the package at that time. So we are having only textbooks. That too, not e-books, only normal books. Okay. Don't think I'm 1980s. I'm 2000 only. Okay. It is not 1980s or 1950s. Right. That is too worst. Right. So I used to prepare in 3 textbooks. At the end of the 3rd textbook, I used to get confused. The final output is confused. Why I used to confuse, because each person used to write in the different notations. One person will write in a different notation, one person will write in a different notation. Because in each textbook, what is the mistake I have done is, for this concept, I have opened directly the page number. For example, if I want to learn the linear regression in this textbook, means I have went directly in which page number it is available. I used to see in the index page, if it is available in the 130th page number, I used to open directly 130th page number. Next, if I want to read the decision tree from this textbook, I used to open directly whatever the index number of wherever the page number of decision tree is there. If it is in the 340, I used to open directly 340 page number. Then at the end, my final output is confused. Then for this, what is the solution means? I used to open again textbook 1 only, but this time page number 1 I have started. One textbook only, started from the ending and ended whatever the last page is there. Finally, I have completed the textbook. Then I have moved on to the second textbook. Then answer is, as of now, what you are saying. Right? Today, whatever the knowledge I am having is whatever the way we have prepared. Not only me, whatever the trainer, whoever the trainer or whoever the person, whoever are working, whatever the way they have prepared, that makes them. Right? So we should not get confused, means we should not take ourselves different. So for example, one of my friend at the time, college days, one of my friend, every exam one night before, in my room, at least 10 members will be there. Okay. Combined studies. Name is combined studies, but other things, right? Now, we used to have 10 members before the exam, and everyone will ask the common question, SRK, tomorrow's tell 4 questions, which damn sure. They'll ask me. I'm not sir, but they know about me, so they'll ask. And I used to explain. At that time, only teaching was started, right? So I used to explain like that. Now, whatever the things are there, this one day before, every student wants the important questions. One day before, that too. Tomorrow exam is one day before only. Important questions. Second, important questions with page numbers also in the textbook. Important page numbers in the textbook. Within that page number, tick marks again. From where you have to start, where you have to end. That part also we have to tick. Okay. So they will by heart that part as it is. If possible, they'll create something. Okay. So they'll create with respect to what are the slips or what are the things, mini booklets, Xerox, micro Xerox, whatever it is. Right. So they'll make sure that this part is important. Now, the question is, if this is only important, directly page number 180 page number, that is the important question it seems, then why the order was created 1 to 1, page number 1 to 179? Directly he can start the textbook also from 180 page number only, right? The author can create a textbook, only important questions textbook, right? So that it will be more popular and students will be buying that book easily. Exactly important questions. Tomorrow exam, in the examination hall, that book is there also. It is sufficient for passing the exam. No supplies will be there. Minimum guarantee pass will be there. Directly the authors can create like this only, right? Why they have created from page number 1 to 179? Directly they can go to the page numbers which are important pages, which are important questions for the exam perspective, which are the important for the real-time concepts, which are not important, they can remove, right? In the statistics textbook also, this much of statistics textbook, 400 pages to 500. Inside that, only important concepts only will be there. Somewhere important, this is not important. For whom? For whom it is not important? For whom it is not important? Right? This is not important, this is not important. If it is not important, then other also can erase that one, right? Delete. Then instead of 400 pages of textbook, it will come to 40 pages or 50 pages only. Material, study material, it will come, right? Then why it is called as textbook? Directly it is called as study material. Not a study material also, exam material, which is used for exam purpose. Right? But here the thing is, each and everything are important. So when you are preparing, why I have told all these things means, obviously the students, they are learning from different sources, different websites or different sources. There is nothing wrong in the learning different sources, but only remember one thing is, notations, each person will follow in a different way. Each person will write in a different way. I think you have already observed this one. Who are following multiple sources, they have already observed this one. So if whatever the person you are traveling, whatever the person you want, from wherever you want to learn, follow from the starting, then only it will be easy. If you come in the step by step, automatically it will be easy. If you move in a zigzag way, any subject will be a difficult subject. Not only data science, any subject in the world, if you want to learn, miss, come in a step by step process. No, don't go in a zigzag way. Step by step process will take more time. Important questions will be completed in 1 hour, might be, but learning the subject will not be completed in 1 hour. It will take so much of time. 100% it will take so much of time. Plan accordingly, not for 1 hour, not for before the exam, not for before the certification, asking the sir what type of certification questions will be there, sir, can you give the sample questions, if possible certification questions directly, what are the questions you are having, please share us, sir. Instead of asking this one, prepare with respect to the concept wise. Why I have told you already this one is, once again, for the notations. So here the notations in the linear regression, we have used the notations called as y is equal to beta 1 beta I xi plus beta naught is the notation. In the same thing in the deep learning, it is called as wi xi plus b. Same to same. The concept will not change. Notations only changes. Now, here, first it is going to process this information. Sir, how these weights are selected? Okay, for wxi plus b is clear. Now, how these weights? First weight, weight 1, weight 2, weight 3. W1, W2, W3. How you are going to initialize the weights? From where you are going to give the weights? How the weights are calculated? First step, weights are initialized randomly. They are initialized randomly. Randomly initialize. So you are initializing randomly. Sir, I am initializing this one as 10,000, 4,000, 10 lakhs, something I am initializing. Now, after initializing, randomly you have initialized. Now you calculate the wi xi plus b. W value is there, x value is there. W value is there, x value is there. W value is there, x value is there. Corresponding x value is there. So now you are going to calculate the sigma wi xi plus b value. If some b value are considering as 0, if you consider bias as 0 also, you can consider bias of 10 also, whatever the bias, some bias, randomly bias. You are initializing the weights and bias randomly. Once you are going to calculate this one, after this is the first step. First step is calculating the sigma wi xi plus b. Second step is called as activation function. So once this is calculated, now this information, whatever the information is there, this information will be passed into the activation functions. Now, what are the different types of activation functions we are having? First step, it is going to do the sigma wi xi plus b. If the b value can be even 0 also. Sigma wi xi plus b is the first step, step number 1. Right? If the, for example, y is equal to mx plus c, equation is there. C cannot be 0. C can be 0, right? If the C is 0, it will pass through the origin. The line will be passing through the origin. Y-intercept is equal to 0 means passes to the origin. That's it. C also can be positive, C can be negative, C can be 0. C can be anything. Similarly, M also can be positive, M also can be negative, M also can be 0. If M is equal to 0, it is called as a horizontal line. If M is equal to 0 means it is called as horizontal line. If C is equal to 0 means it is passing through the origin. The line will passes through the origin. Because y-intercept is equal to 0 means y-axis it should not cut any point. None of the point it has to cut means it has to send into the origin only. Right? Now, here we are having with respect to this y is first step. First step, sigma wi xi plus b. Second step, whatever the answer you have got, this answer you are going to take in the activation function. You have to take this value, you have to send this information to the activation function. Whatever the output you have got, this you have to send in the activation function. After sending the activation function, whatever the output is there, that is the output of the neuron. You have to share to the second one. Now, what are the different types of activation functions we are having? Okay, so here I'm having only with respect to something data set like this. So before moving to this example, let us see different types of activation functions. What are the different types of activation functions are there? Now, what is meant by activation function means conversion. Like if you go with this logistic regression. Logistic regression. In the logistic regression, what is the process? Can anyone tell me? Step-by-step process in logistic regression. First step, it is going to do beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3, so on up to beta n xn, whatever it is there. Now, whatever the y hat you have got here, this will be substituted in the sigmoid function. Means p hat you are going to calculate. That is 1 divided by 1 plus e to the power of minus y hat. This value you are going to substitute here. And after substituting this one, that is nothing but e to the power of divided by 1 plus e to the power of y. Right? Both are same. Now, once you have substituted here, you are going to get some probability value. And based on the threshold value, you are going to either 0 class or 1 class. Right? Now, this value has been converted to probability. You have converted to probability by using the sigmoid function. This sigmoid function in deep learning is called as activation function. In logistic regression, it is called as normal function. In deep learning, it is called as sigmoid activation function. Name is sigmoid only. Once again, it is sigmoid only. But it is called as activation function. Right? So they have created this one as activation function. See here. Suppose I have got some equation like this, where I'm having only two input columns. Are this is input column x and y. First step, what is the first step? You have to calculate y hat is equal to beta naught plus beta 1 x. This is the step number 1. Step number 2 is you have to predict the probability by using the sigmoid function 1 plus e to the power of minus y hat. And if the p value is greater than or equal to 0.5, it comes under class 1. If it is less than 0.5, it comes under class 0. Threshold value, we are considering by default threshold value is 0.5. This is logistic regression. Now the same thing, see here. So where you are having with respect to the output variable either 0 or 1. Only 2 classes. Now same you are going to apply. Now first you are going to calculate y is equal to mx plus b. Now notation was they have kept as b. They have kept, sorry, not they, I have kept. Okay, I have kept as b. Sometimes this image I have copied somewhere only. Right? So whatever the image is there, this y is equal to mx plus b. Different notations. Don't worry about the notations. Just understand the concept. This is slope and this is y-intercept. Now this is the first step. Second step is whatever the value you have got that you have to substitute and you are going to convert to the sigmoid function. Now, for example, you have calculated the beta naught and beta 1 like this. Any person, for example, 35 age is there. Whether he will buy the insurance or not means first 35 you have to substitute here. And you will get some value. You will calculate that value. This is nothing but wi xi plus b. Here, how many input variables are there? One variable only is there. So, w1 x1 plus b. What is w1? 0.042. What is x means? This value, whatever the value you are going to substitute. B value is minus 1.53. Now in the neuron, 2 steps I have told you, right? Step number 1 is calculating wi xi value plus b. In this case, w1 x1, only one variable is there. So 1. If 2 variables, 3 variables are there, whatever the things. Once you have calculated, step number 2. What is the step number 2? Activation function. Means first you have calculate this one, that is 0.042 into 35 minus 1.53. You will get some value here. Let us calculate that value, whatever the value. 0.042 into 35 minus 1.53. That is minus 0.06. First step is completed. In the neuron, inside the neuron, first step. Inside the neuron, second step is activation function. Now z is equal to, z is nothing but probability. Now this p value is equal to 1 divided by 1 plus e to the power of minus y, which is nothing but 1 divided by 1 plus e to the power of minus 0.06, which is nothing but 1 divided by 1 plus e to the power of 0.06. Now you got the value, whatever the value you are going to get, that is the output. You have to send that output to the next neuron. That is the output of the neuron. After converting to sigmoid activation function, here I have considered the sigmoid as the activation function. Whatever the activation function is there, You have to pass this information to the sigma, to the activation function, and you have to calculate, and whatever the output you have got, that output you have to send to the next one. Is that clear, guys? Clear? Here in this case, it is a sigmoid activation function. In this example, like this, we are having multiple activation functions are there. So whatever the activation function is there, activation function is nothing but substituting this y value in that function. Whatever the function is there, substituting this value inside that and giving the output. For example, age is equal to 43 is there. Substitute the 43 here and substitute in this one, and whatever the output is there, send that one. Whatever the value is there, just calculate with that value and send the information. Right? For example, you are having 3 input variables. 1, 2, 3. Age, income, and education. 3 input variables are there. Now, what is the equation? This is the equation, which is nothing but sigma I xi plus b. So here, wi xi plus b, that is w1 x1 plus w2 x2 plus w3 x3 plus b. So now you require the 3 values. In order to calculate the y, you require the 3 values. Once you calculate the 3 values, you are going to substitute here, and this information you are going to send to the activation function. Whatever the output you have got, that will be sent to the activation function, and the activation function will process that information and it will then send to the output. So let us assume this is the 3, whatever the beta naught values are there, this is the beta naught values, that is beta 1, beta 2, beta 3, that is w1, w2, w3. In the linear regression or logistic regression, we used to work on beta 1, beta 2, beta 3. In deep learning, it is called as w1, w2, w3. You have to use the word of w1, w2, w3. Okay, they are called as weights. In that example, it is called as slope or coefficient. In the max, it is called as slope. In machine learning, it is called as coefficient. In deep learning, it is called as weights. Concept is same. Okay. So now whatever the weights are there, the weights you are going to multiply with that value and sigma wi xi plus b, and you are going to send into the activation function, and it is going to give the output. Now, what are the different types of activation functions are there? We are having total 5 different activation functions are there. 5, not 5, 6. 6 activation functions are there, out of which the first activation function, 6 activation functions. Total 6 activation functions are there. First one is called as step function. First one is called as step function. Step function means first you have to calculate the y is common. In everything, calculation of y is common. That is sigma wi xi plus b. Y hat is common. Calculating up to here, it is common. Okay, the first step of neuron is common in every function. The first step is common. Whatever the output you have got, this output, if the output is greater than 0, if the output is greater than 0, okay, then the output is considered as 1. If the value is greater than 0, it is considered as 1. If the value is less than or equal to 0, it is considered as 0. It will convert like this. For example, you have got earlier, what is the earlier example? I have calculated that 0.042x minus 1.53. X is equal to 35, I have substituted. What is the y value I have got? That is nothing but 0.042 into 35 minus 1.53, which is minus 0.06. Now, since this value is less than or equal to 0, now it is going to send from this neuron. If the 35 is the information, the output of the neuron is 0. If 35 is the information for this neuron, the output is 0. Because here, whatever the value you have got, it will convert that one to, if it is greater than 0 means, it will send as whatever the value 1. For example, it is instead of this 0.06 plus 0.06, the output is 1. If the value is less than 0 or equal to 0, 0. This is called as step function. Step means in the output, you are going to have either 0 or 1, only 0 or 1. So what is the range? If you write the range means 0 and 1. These are the two values. Both are included. Both are included. 0 or 1. Either 0 or 1. Only these two options you'll get in the output. If you are using the step function, the output of the step function will be either 0 or 1. There is no other option. Next type of activation function, second type is called as sigmoid function, which we have discussed earlier. First, it is going to calculate the same. Why is step 1 is remains same. It is not going to change this one. This part is then. After calculating this one, if whatever the y is, this value is there, it is going to substitute in the equation, sigmoid equation, that is 1 divided by 1 plus e to the power of minus y. And whatever the output it has got, it will send that output to the outside. Now the range of this one is from 0 to 1. The output is from 0 to 1, where 0 is not included, 1 is also not included. You can't get 0, you can't get 1. The values lies between 0 to 1 because the probability lies between 0 to 1. Right? Sir, why it is not equal to 0? Why it is not equal to 1? For example, P is equal to e to the power of 5 divided by 1 plus e to the power of 5. If it is equal to 1, assume that it is equal to exactly 1. Now, 1 plus e to the power of 5 is equal to e to the power of 5. How 1 will be equal to 0? It is possible. So that is the reason never it is going, numerator and denominator cannot be equal, right? Never it will be equal. When compared to numerator, for numerator, whatever the numerator, denominator is having plus 1. How these both will be equal? Whatever the numerator you consider, whatever the value you consider, denominator will be plus 1 to that. So never the numerator and denominator will be same. It is not possible. So 1 is not possible. Never you can get the 1. At the same time, 0. Coming to the 0, e to the power of 5 divided by 1 plus e to the power of 5 is equal to 0. Means e to the power of 5 is equal to 0. E to the power of 5 should be 0. Means log to base e, e to the power of 5 and log 0 to base e. Then y is equal to log 0 to base e, which is nothing but log 0 is infinite. That is also not possible. So 0 is not included, 1 is also not included. This is the reason. In order to get the output as 0 miss, then y should be infinite value. Y should be infinite, then only output will become 0. Otherwise, the output will not become the 0. So it is going to give between 0 to 1, where both are not included. These brackets, whatever these brackets are there, if this is normal bracket means this value is not included. If this is the square bracket, what is the meaning of this one? What is the difference between this and what is? In this case, 0 and 1 not included. Both are not included. In this case, 0 included, 1 is not included. In this case, both are included. 0 included, 1 also included. For which one bracket, square bracket is there, that is included. For which one square bracket is not there, that is not included. Normal bracket means not included. Square bracket means included. That is the mathematical notation. Right? That is the reason for all the infinite values. Whenever you see the infinite word, they'll keep a normal bracket on. Never the square bracket will be there after the infinite word in the max. Because infinite value, no one knows. None of them knows. Right? So 0 to 1. Range is 0 to 1. In between 0 to 1 will be there, where 0 and 1 is both are not included. That is the second activation function. Third activation function is called as tan h. Guys, we'll complete activation functions and we'll stop. Okay, minimum we'll complete the activation functions. Tan h, where tan h, again it is going to calculate. The first step remains constant. In the none of them, the first step changes. The first step of neuron in every time it is same. The first step remains same. Only the second step changes. Second step is where tan h function is equal to e to the power of Just a minute. I have forgot the formula. Tan h function is 1 minus e to the power of minus 2 y hat divided by 1 plus e to the power of 2 into y hat. This is the formula for tan h. Okay, that is whatever the output is there, some output we are considering as some name it as some kind of t is equal to 1 minus e to the power of minus 2 into y hat. Whatever the y hat you have calculated here, that value you have to substitute here. Divide by 1 plus e to the power of plus 2 y hat. Y hat is nothing but whatever you have calculated here. That is your y hat. Okay. So whatever the notation you have used here, use the same notation here. In the notes, if you have written y miss, use the y. In the notes you have used it for z miss, use the z. Whatever the things you are using, use the same here. This value you have to substitute here. This value you have to substitute here. This value you have to substitute here. Right? And for this, it is going to range is minus 1 to plus 1. The range is going to be from minus 1 to plus 1. Range of tan h is minus 1 to plus 1. Right? Next. Activation number 4. Most important activation function. 99.99999% will use this one. Okay? Which is called as a ReLU. R, small e, caps lock L, caps lock U. ReLU is the name. ReLU means rectifier. RE stands for rectifier. Rectifier. L stands for linear. U stands for unit. Rectifier, linear, unit. ReLU as the activation function. Okay. Now, in this case also, we are going to do first y hat is equal to, in this case also common. Y hat is equal to wi xi plus b. Commonly you have to calculate. Now, if y hat value is less than or equal to 0, it is converted to 0. If y hat value greater than 0, whatever the y hat is there, y hat only. It is not going to convert. Negative values will be rectified. Normal values will be normal. Positive values, positive only. No change in the positive values. Negative values will be converted to 0. That is the rectification it is going to do. All the negative values will be converted to 0. Positive values, no change in the positive values. So now the range is 0 to positive values as it is, right? Infinite. Positive value, there is no limit. Whatever the value you have got here, for example, 40,000 you have got. 40,000 only you will send as the output. 50,000 you have got. Sigma wi xi plus b. It will send as it is. You have got minus 50,000. 0. It will send output as 0. Right? Why every time it is happening? Right? So whatever the sigma wi xi plus b is there, that value is going to be converted. Next one is called as leaky ReLU. Leaky ReLU. ReLU only, but leaky. Leaky means, sir, sigma wi xi plus b, if it is minus 50,000, simply converting to 0. Why you are doing like that? If you convert to 0, what happens means the neuron will dead. Because there is no use of that neuron, right? The output of neuron is 0 means there is no use of that neuron. At the end, there is no output. So instead of dying that neuron, why we can't convert? So to some value. If the y hat is less than or equal to 0, convert that value, multiply that value into 0.00000000000 something into that value. Means minimize that negative value. Neuron will not die, but there will be no use. Is that clear? Means instead of If you want to kill a person, assume that you want to kill. If you want to kill the person, you are having two options. Option number one is directly kill, simply kill. Second option is brain dead, kill the brain. Now the brain will not, if the brain is not there means, though the person is there also, there is no use, right? Now the person is alive, but no use. Person will be available, but there will be no use. Simply remove the brain. Then no need to kill the entire body. Just kill the brain only. Equal to that one only. Both are same. Right? The same thing is called as rekireru. Rekireru, the negative value will be converted by multiplying 0.000 some value. You are trying to reduce that value. Okay. Now what happens? That value will be there, but there will be no use of that value. Negligible value. Value is there means neuron is alive. Neuron alive, but no use of that neuron. Here the neuron was killed directly. Here the neuron was alive. In both the cases, that neuron is no use. Sir, keeping of unused this one, waste na? Keeping is waste, right? So that is the reason it is failed. This is click. That is the reason. This is having the overfitting problem. Rekireru has the overfitting problem. Unimportant neurons are more miss waste. Processing time is waste, everything is waste, and at the same time, overfitting also will be there. Now, what is the range of Rekireru? Negative values also can be from minus infinite to plus infinite. Though it is reduced also, some value will be there, right? That value we don't know. So since we don't know, we are writing as minus infinite to plus infinite. This is the fifth one, which is called as Rekireru. The last one, sixth one, is called as soft max, which is very soft. Right? Soft max. This soft max is used when it is having only multi-class problem. For multi-class problem, one and only option we have the soft max. There is no other option for it. For remaining top 5, we can have different, but soft max 100% we have to use for multi-class problem. What is meant by soft max means for each class it will calculate the probability. For each class it will calculate the probability. Which class is having the higher probability, it will select that class as the output. For each class calculates the probability. For each class, it calculates the probability. It calculates the p-value. How many classes are there? For each class, it will calculate. Right? Done? Have you, for this example, best example is, have you seen any kind of WhatsApp with respect to this, sorry, not WhatsApp, in the WhatsApp status also, and some kind of Android apps are there. Like if you give your face, if you start your selfie, whatever the camera is there, front camera, if you turn on the front camera, now it is going to detect your face and it will identify what is the probability that, sorry, it will say how much correlation you are having with respect to your face to the zebra face, your face with respect to lion face, your face with tiger face. It will show, right? So in the back end, it was trained with multiple images of dog, multiple images of elephants or lions or tigers or whatever it is. Each class it was trained, and it is going to calculate for tiger. With the tiger, what is your face matching probability? With lion, what is your face matching? With like anaconda, how much your face is matching? With respect to python, how much face you are matching? With respect to giraffe, how much face you are matching? And finally, out of calculating all of them, which one is having highest miss, that it is going to predict. Right? So whenever you are having the multi-class problem, then you are going to select the softmax as the activation function. It is going to calculate the probability for each class. How many classes are there? For each class, it will calculate separately probability, and whichever is having the highest one. And the range is also 0 to 1 only. Obviously, it is 0 to 1. Probability only, right? Like sigmoid. Right? So these are the 6 activation functions we are having. And which type of activation function has to be selected and where we have to select, and how it will process, that we are going to see in the tomorrow's class.